All right, we're about to begin Unit 10, which is circles. On day 1, we're going to talk about the parts of a circle, how to find arc length and sector length. This day is probably going to be one of the longest days because it's a lot of vocabulary and terms that we have to know in regarding a circle. So prepare yourself. The first thing is to know the formal definition of a circle, which is a set of points on a plane that are equidistant from one point, which is the center. So to our right, we have a circle. To properly name a circle, you use the center of the circle to name the circle. So our circle on the right is called circle P. We could write it out using the word circle and the letter P, or you can use the circle symbol and then put a P. So circle shape symbol with a P is another way to name the circle. A radius is a segment with endpoints at the center of a circle and on the circle. So we briefly talked about this last lesson when we were talking about our polygons. But again, a radius starts at the center. So in this case, it would start at P and it would hit the edge of the circle. So a radius is a line segment in which it has two endpoints. Again, one being the center, the other one being some other point. So let's say this is point A. So the radius is called PA or AP. But again, when you name a radius, you must draw that line segment bar above the 2 points, the 2 endpoints, that is. The chord is a segment with endpoints on the circle. So a chord is any line on the circle. So again, it must go from point to point on the circle. And it can be anywhere. It doesn't necessarily have to be through the center. So let's say these are B and C. So this chord is BC or CB. And again, it does not have to go through the center. It can, but it doesn't have to. A diameter is a chord that passes through the center. So the diameter must go through the center. It has no choice. And it touches each edge of the circle. So again, it has to go through the center and touch each edge. So let's say this is D and E. So the diameter would be DE or line ED. Now there's some extra information that you need to know about the diameter. Since the diameter goes through the center, it's basically one radius and another radius. So the diameter is equal to 2 times the radius. Again, 1/2 of the diameter is the radius. So if you put 2 halves or 2 radii together, you have the whole entire diameter. So in that same manner, you can look at the radius as being half of the diameter or the diameter divided by 2. Same thing. So don't forget those two facts. Their circumference we talked about in the last unit, but it's the distance around a circle. And it's the same as one revolution of a wheel. So the circumference was found by taking 2 times pi times the radius, or we also said it was diameter times pi because 2 times the radius is equal to the diameter, or it's the same thing as the diameter. So this 2 together with this r make the diameter. So that's, again, another way to represent circumference. Pi is known as the ratio of the circumference to the diameter of any circle. So again, pi is equivalent to circumference divided by diameter, which is also the same thing as circumference divided by 2 times the radius. And it's true, you can take any circle, no matter the size, and divide the circumference with the diameter, and it'll be approximately 3.14, which is the approximation for pi. Inscribed. A polygon is inscribed in a circle if all of its vertices lie on the circle. So to the right, we have a circle with a four-sided polygon inside. So we can say that quadrilateral LMNP is inscribed in circle K. So this four-sided polygon is inscribed in this circle, which is called circle K because of the center K. Inscribed is another way of saying it's inside of it, but again, all of the vertices must touch the circle, which they do. Circumscribed. A circle is circumscribed about a polygon if the circle contains all of the vertices of the polygon. So using the same picture at the right, we can say circle K is circumscribed about quadrilateral LMNP. Again, because it covers the entire polygon and the circle touches each one of the vertices. Concentric circles are circles with the same center but different radii. So another way of thinking about concentric circles is like a bullseye. It's basically circles within circles. So here's one. There's two. There's three. Again, they have the same center. So let's say the center is point A, but each one of them has a different radius. Well, of course, that looks obvious because each one is getting bigger. So the smaller circle will have this radius. And then so for example, the smaller circles might have a radius of 1, where if I add 2 more onto that one, that means the medium size would have a radius of 3. And if I add on to that, the larger one would have a radius of 6. So again, they share a center K, but each radius is different. And radii is plural for radius, just in case you didn't know. A central angle is formed by two radii, and the vertex has to be the center of the circle. So on our circle at the right, our central angle is named, would be angle APB, or you could say angle BPA, or you could say angle P, because they do not share, this angle does, the vertex of this angle, sorry, is not being shared by another angle. If the vertex is shared by another angle, then you must name it with three letters. But for this example, it's not shared by anything else at this time. So again, we can simply say it's angle P. An arc is an unbroken part of a circle. So in this circle, this segment or piece between A and B, the curved part, is considered an arc. So to name it, we would say arc A, B, and draw the arc symbol above it, or you could say BA. Sometimes it requires three letters to name an arc, and we'll get more into the depth of that in just a moment. To find the measure of the arc, it's the number of degrees, and it'll be the same measurement as the central angle. So let's say angle APB measured 35 degrees. So since the measure of angle APB is equal to 35 degrees, that means the measure of arc AB is also going to equal 35 degrees. Again, the central angle and the arc measure are equal. A minor arc is an arc whose measure is less than 180 degrees. A major arc is an arc whose measure is greater than 180 degrees. A semicircle is an arc whose measure is exactly 180 degrees. So if I look at my picture on the right, I could say that arc AC is a minor arc because it appears to be less than 180 degrees. It appears to be less than half the circle. So I could say AC, arc AC, or the measure of arc AC is less than 180 degrees. So it is a minor arc. Oops. That's supposed to be R, and this is supposed to be a C. Now, a major arc has to be named with three letters, without a doubt. A minor arc, it can be, but it doesn't have to. But a major arc must be named with three letters. So for this example, I could say a major arc, or for this picture, could be arc CDA. So the measure of arc CDA is greater than 180 degrees. So it's a major arc. Another way to find the measure of the arc is you can take 360 degrees minus the measure of arc AC, so the minor arc, to find the major. So 360 minus the minor is equal to the major. Because if you look at it, if I were to connect both highlighted portions, it forms the whole circle, and we know the whole circle is 360 degrees. A semicircle in this example would be arc ACD, because a line AD goes through the center, so it's the diameter of the circle, and so the arc formed by the diameter of the circle will always be a semicircle, and the diameter cuts the circle in half anyway. So again, I was saying the name of the semicircle would be arc ACD. Again, because it's formed by the diameter. So if it's formed by the diameter, it's always a semicircle. So the measurement is equal to 180 degrees. Congruent arcs are arcs that have the same measure. So for example, if I were to draw the radii CP on my picture over here, it would mean that the arc, well, we already know, it would mean that this arc, or this angle, is 90 degrees, and this angle is also 90 degrees. So that means arc AC is congruent to arc CD. So again, I was saying the measure of angle APC is equal to the measure of angle DPC. So that means the measure of arc AC is equal to the measure of arc DC. And it would be 90 degrees. On this example, it tells us that GJ is the diameter of circle K. Identify each arc as a major arc, minor arc, or semicircle. Then find its measure. All right, so GH, or arc GH, is right here. The central angle that is connected to GH is angle that measures 122 degrees. So that means the measure of arc GH is equal to 122 degrees, which is less than 180, so it's a minor arc. I don't know why there's a delay on my computer right now. All right, the GLH. So start at G, go to L, and all the way around to H. To find this one, I would take 360 degrees minus the minor arc, which is GH, to find this measurement. So that would be 360 degrees minus 122 degrees. $238 degrees. Is the measure of arc GLH. So since it is larger than 180 degrees, it is a major arc. Now arc GLJ GLJ is formed by diameter GJ, so it is a semicircle. So that means the measure of GLJ, arc GLJ, is equal to 180 degrees. We are going to have to pause right here for a short moment in order to reconvene and finish the lesson.